Let us discuss this example. Okay, the statement or the question I have written on a board. See, it is looking difficult. Okay, but in a simple words we can say, you know, BPR and BQS, these are open balls. Okay, BPR is open ball in XD1 first matrix space, and BQS, this is second open ball in another matrix space, I think YD2. Okay, then if you take cross product of these two balls, then it is an open set in a product matrix. This thing we have to prove. Okay, so what we have to prove, all of you understood now. So if you have the first ball is in first matrix space, second ball is in second matrix space, if you take their cross product, then the resultant the set will be open set in a product matrix space. This thing we have to prove. First I will prove that it is non-empty, then we will talk about it is an open set. See, clearly P belongs to BPR. See, that point which is the center of ball, obviously it lies in a ball, and Q belongs to BQS. Again, it is the center of that ball, so obviously it will lie in a ball. Implies P comma Q is an element of BPR cross BQS. So this is P comma Q is a element of that product set. Okay, first ball cross second ball. So there is one point, okay, belongs to that set. So therefore this set is non-empty. BPR cross BQS not equal to phi. Okay, so now we will prove that it is an open set. Now we will prove that BPR cross BQS is open in which matrix? They have mentioned here in X cross Y D. Okay, that product matrix D is defined in this way. A maximum of using that definition it is defined. So we have to prove that it is an open set. Tell me, what is the technique to prove any set is open? We take one arbitrary point and we prove that there is ball, okay, which center that point and some radius lies in that set. So we can declare it is an open set. Same technique I will use here to prove it is open. So let I am taking one point A comma B belongs to BPR cross BQS. B any arbitrary point. B any arbitrary point. Okay, so that means what can we write? Tell me. So first point lies in first ball and second point lies in second ball. So A belongs to BPR and B belongs to BQS. Implies point A lies in first ball. So the distance between A and P is less than R. Just a minute, just a minute. See, okay, instead of that, what will I do? See, you know that every open ball is an open set, but every open ball is an open set. You are familiar with this thing, getting? So can I say therefore this ball is open set because every open ball is an open set. This ball is also open set because every open ball is an open set. So therefore what can we say? BPR is open set, but where? In a first matrix XD1, and BQS is open set where? In YD2. Getting the point? First ball, it's ball, every ball is an open set, therefore it is open, but it is the first matrix, and this ball is open set in a second matrix. Okay, so there is no more space, so I suggest you to make a screenshot of it. After that we will go further. See, BPR is open set and A belongs to that set. So you know the definition of open set. So therefore there exists R1, and for this set, this is also an open set and B belongs to that set. Therefore there exists R2, and R2 greater than 0 such that what can I write, tell me? Open ball with center A, radius R1, subset of BPR, and open ball with center B and radius R2, subset of open ball BQS. So this thing we have got. Okay, we have got two radius R1 and R2. What will I do? I will select minimum of R1 and R2. Let R0 is equal to minimum of R1 and R2. So now my claim is, see, clearly I should mention clearly R0 is greater than 0. Clearly it is greater than 0 since both of them are positive. So minimum of these two is also positive. Let me remove this part, it is not required, and you have also taken its screenshot. Okay, just let me remove it. Okay, it is removed now. See, so what is my claim? I will write here. So my claim is open ball with center AB. You remember initially we have taken that point AB with radius R0 is subset of BPR cross BQS. See, this thing we have to prove na? We have to prove this set. This set is open set. Okay. And now this is my claim, open ball with center AB and radius R0 is subset of this one. If we will prove it, we can declare it is an open set. How to prove one set is subset of other? We take one arbitrary point of this set and we will prove it is in second set. Let us take arbitrary point x comma y belongs to B, AB, center AB, radius R0. So you know that if any point lies in a ball, distance of that point from the center of ball is less than radius. So therefore what can we write? Tell me. So therefore distance of that point xy from AB is less than its radius. But see, what is definition of D? Definition of D is this one. They have defined, this is the metric defined on product space x cross y. So by this definition I can write this is maximum of, I am using this definition, maximum of D1 of x comma a, first two elements we have to take, D2 of second two elements y comma b less than R0. See, maximum of these two is less than R0. That means each of them should be less than R0. So therefore D1 of x comma a less than R0 and D2 of y comma b less than R0. But you remember the definition of R0? Definition of R0 was minimum of R1 comma R2. I think it is here. Yes, definition of R0 is minimum of R1 comma R2. So therefore R0 should be less than or equal to R1 and R0 should be less than or equal to R2. Shall I combine these two inequalities? So therefore what can I write? D1 of xa less than R0 and R0 is less than or equal to R1. So this is less than R1 and D2 of yb. This is less than R0 and R0 is less than or equal to R2. So this is less than R2. So implies, what can I write? X belongs to B, center X, radius R1. Sorry, center A, radius R1. Distance of X from A is less than R1. So that means definitely X lies in a ball having center A and radius R1. What can I write for this inequality? I can write Y belongs to open ball with center B, radius R2. So that means X comma Y lies in a product, okay, of these two balls B, R2. Just a minute, yes, we have got this one. I hope all of you understood. Okay, make a screenshot of it, please. See, one thing we can do here, one thing we can do. So instead of this one, what I'm going to do, see, x belongs to BAR1. I will call it as star. X belongs to this ball, but this ball is subset of BPR. So therefore X belongs to BPR, right? And Y belongs to B, see, open ball with center B, radius R2, but it is subset of BQS. So Y belongs to BQS. So now I can write X comma Y belongs to product of these two balls. Okay, make a screenshot of it. After that we will go further. See, therefore what can I write? Implies X comma Y belongs to open ball with center P, radius R, cross open ball with center Q comma X S. Okay, so that means finally what can we write? Therefore we can conclude now. We had taken this point from open ball with center AB, radius R0, and finally we proved it is in product of these two balls. Okay, so therefore we can say this open ball with center AB, radius R0 is subset of product of these balls. Okay, let me remove this part. So therefore this is subset of product of these two balls. So that means, and that AB was arbitrary point, so it is true for each point, okay, of this set. So therefore we can declare it is an open set. Therefore BPR cross BQS is open in a product matrix space X cross Y comma D. In this way we have completed this example. Make a screenshot of it. After that we will stop. Thank you. Bye bye.